This video is going to explain about the subtopic 4.1, which is about molecular and structural formula. The learning outcome for this subtopic 4.1, molecular and structural formula: A. Define structural formula. B. Show structural formula in the form of expanded, condensed, and skeletal structure based on molecular formula. And C. Classify carbons into primary, secondary, tertiary, or quaternary, and hydrogen into primary, secondary, and tertiary. Structural formula. Structural formula of a compound is a formula that shows how the atoms in a molecule are bonded to each other. There are three types of structural formula, which is the first one is expanded structure, the second one is condensed structure, and the last one is a skeletal structure. So we are going to learn about all these three types of structural formula in this subtopic. So the first one is expanded structure. Expanded structure shows all covalent bonds between atoms. So it does not represent the actual shape of molecule. For example, if we have a molecule with C4H9 molecular formula, if we convert it into expanded structure, the structure will be like this. All of the covalent bonds between carbon and hydrogen atoms are shown in this structure. Let's look at the example. For the first one is alcohol with the molecular formula of CH3CH2OH. So we can convert it into expanded structure with this representation. The next example is carboxylic acid with a molecular formula of C2H5COOH with this expanded structure of the molecule. Next, we are going to look at the condensed structure. Condensed structure is a structure where it does not show single bonds between carbon and hydrogen atoms, but double and triple bonds are shown. All atoms that are attached to a carbon are written immediately after that carbon. For example, if we have C4H9 molecule, the C carbon atom with 3 hydrogens will be written as CH3. So, the condensed structure of this molecule would be CH3, CH2, CH2, CH3. So this is the condensed structure of the molecule. The next one is example of cyclohexane with the formula of C6H12, which is a cyclic compound. So the cyclic compound will be written as follows. The other example is CH3CH2COOH to represent the expanded structure of carboxylic acid. In condensed structure, we need to use the bracket symbol in order to show heteroatoms or functional groups or alkyl groups at the side chain. For example, if we have propan-2-ol, this is the expanded structure of the molecule. So if we convert it into a condensed structure, we can write the molecule in the condensed structure like this, or like this, with the bracket between the OH group, or like this. All of these represents the condensed structure of the molecule. The next example is 2-methylpropane. With this one is the expanded structure of the molecule. So the condensed structure of the molecule can be written like this. So this molecule can be written with the bracket symbol in order to represent the alkyl group bonded together at the same carbon. The bracket symbol can also be used in condensed structure in order to indicate the repeating unit in the structures. For example, if we have octane with C8H18 formula, this would be the expanded structure of the molecule. So, the condensed structure of the molecule would be like this. Since we have the same repeating unit of CH2 in the molecule, we can write the condensed structure of the molecule like this. So these two are known as the condensed structure of the molecule. If we have molecule with single atoms such as halogens, we do not need to use the bracket symbol. For example, if we have 2-chloropropane with formula of C3H7Cl, this would be the expanded structure. And if we convert it into the condensed structure, the structure would be like this or like this. Now, let's look at the skeletal structure. The skeletal structure shows only the carbon skeletal, and the carbon chains are drawn zigzag and rings are drawn as polygons. The carbon atoms assumed to be at each intersections of two lines, which is what we call as bonds, and at the end of each line. The C atoms are usually not shown, and hydrogen atoms bonded to C are not shown as well. The functional groups are shown in the diagram. The other atoms such as oxygen, chlorine, nitrogen, and etc. are shown in our skeletal structure. Let's say that we have an expanded structure of the molecule. The skeletal structure of this molecule would be like this. Now, let's look at the classes of carbon atom. The first one is primary carbon. Primary carbon is when a carbon atom attached to only one carbon atom. Next is secondary carbon. Secondary carbon is when a carbon atom attached to two other carbon atoms. The next one is tertiary carbon. Tertiary carbon is when a carbon atom is attached to three other carbon atoms. And the last one is quaternary carbon. Quaternary carbon is when a carbon atom attached to four other carbon atoms. Next, let's look at the classes of hydrogen atom. The first one is primary hydrogen, where the H atom attached to primary carbon atom. The next one is secondary hydrogen. The secondary hydrogen is where hydrogen atom attached to secondary carbon atom. And the last one is tertiary hydrogen, where H atom attached to tertiary carbon atom. In general, the classes of hydrogen atom will follow the classes of carbon atom. If we have a situation where the carbon atom attached to four other carbon atoms, which is what we call as quaternary carbon, this carbon has no hydrogen, so there is no such thing as quaternary hydrogen in this kind of molecule. That's all for the video. Thank you very much for watching.